Hey guys, what's up? Welcome to another RMA Fire tutorial and one of my exclusives. This is exclusive content, guys, and I'm very excited to share with you. Happy to share with those members and for those of you who have purchased this tutorial individually. So I don't know if I ever told you guys, but I love working with sand. Sand is one of the most, I would say, satisfying things to watch and play with inside of Houdini. And this is the first part, volume 1 from sand. And on volume 1 we're gonna be covering some very cool results, as you can see in the renders. So we're gonna be talking about some really interesting sand concepts, how to get this specific look that you're seeing here in the final result. And this will set the pace up to some more advanced sand concepts that I'll be covering on the next phase. But with this tutorial, you will be able to understand and do some very interesting simulations. So without further ado, let's have a look at the file that you will receive. Right, so the first thing first is let's go into this geo node and let me show you how I've set everything up. So for starters, I have this really high resolution skull, right? And the reason why this is a skull is because we're talking about the collider. You guys can utilize anything you want, but for me, I wanted to use this skull as the collider, and we're gonna be doing a bit of work on it. So on my setup, I did a poly reduce and I cached this because I wanted to have a low res version of this skull. And then this transform is basically just setting it to, if I hit P here, I just moved centroid to origin and I scaled it to a right scale. Now, when working with sand, you want to make sure that you're working with proportional sizes to what you want to do. So I know that this box is a meter in width and height, and I know that's not the real size of a skull. But if I were to make this skull real size and then try to do the sand sim, it'll be hard to get some collisions and some stuff working. So sometimes it's okay to work with bigger sizes to get the easier simulation results. So we have our skull here. And this can be any kind of geometry, like I said. And I'm deleting the top part and I'm deleting the bottom part. And then I am organizing this so that I can, based on a camera, animate it doing something, right? So my animation here is essentially just grabbing a transform and animating it here and here. If I were to create this from scratch, for those of you who do not know, it would be just a transform, hitting Alt, and hitting that thing, that keyframe, then rotating it in whichever direction that you want to animate it, right? So it could be something like this. Uh, 33 maybe. And then hitting that again, hitting Alt and touching those keyframes, and then this is automatically going to animate it. Okay? So that's all I am doing here. Prepping my animation for the opening and the closing of the skull. Following this, we have one more transform. And what this transform is doing, it is pushing the skull up on the y-axis, right? So same thing, I'm just animating it here, and I am animating a tiny, hide everything, just animating a tiny bit of rotation. Why? Because the idea is for our setup, we're gonna be creating a box or some sort of layer here. And this is gonna be kind of like this. So this is gonna be filled with particles. And then the skull is gonna break through them and come out. So it's almost like it's a pond of sand and the skull breaks through it. So to create this pond of sand, this is how I created it. I made a grid, then my grid has been extruded with a 1 distance, right? So we have this, and then this one right here is extruding inwards, meaning that you have an extrude. We can create it from scratch. Extrude poly, right? We're just moving this here and outputting the back so that the back is closed, or else it's going to be opened. Then we're doing an extrude again and extruding this one inwards. And selecting the extrude front only. So extrude front, here you want to enable it, and then here we want to select it, and it's automatically going to extrude the front like that. And then this one is extruding the front again, but from the second one. So extrude front is enabled. Let's do another extrude. Select extrude front, and then this time we're going inwards. Okay. There we go. And this time we're going inwards. So now we have a box. And we want to isolate the inside of the box to create particles out of this without creating any collisions. We want the particles to fit in this box quite nicely, tightly, and we want the particles to fit in this box nice and tight. So in here I created a group because I wanted to have my whole box in a group. Very simple. We just drop down a group, we connect this here, and we give it a name. I named it Collider. And then on this end, I'm basically deleting the extrude front. So if you drop down a delete, and we connect it here, and we say just delete the extruded front, it's gonna delete this front. But you want to do delete not selected, so that we just isolate this area. Okay, I'm gonna delete this, and now we have the area where we want the particles to be in created. So I just did a little bit of an extrude to it. I added some color to them, and I named this my particles. So it's another group. Now following this, we have a transform so that I could position this in the origin center. And then so that I merged it here just simply to visualize. Alright, so what am I visualizing? I want to visualize that the skull is coming through it properly. So if I hit W here, I will see the wireframe. And then if we see it happen, you're going to see that the skull does that. So we're breaking through the surface. And ideally, if you look at the yellow stuff is inside of our container, and the yellow stuff will be our particles. Hit W again, and we're back here. Alright, so now we have to prep things to create the particles. So here, I created a delete, and in delete, I'm deleting the collider. See our group here, because I just want to have the particles isolated, but using this transform to place them in the scene. So place on scene. Now we have the deleted particle area, and I'm creating VDV and then converting the VDV to polygons. The VDV, you can control the voxel size here. So after this delete with the VDV, you can kind of like smooth out the mesh a little bit and control the voxels. Here, like if you were to do 0.5, it has like voxels, so when you convert it, you'll see it has less resolution. But I like this because it's nice and packed and looks pretty good. Now after this, I am doing the vellum constrained grains. So basically, if you do the type vellum grains, it will give you this node, and when we connect this, it will not do anything. Now what we need to do is select this and create points from volume, and that means that it's going to create some points that we can't even see right now. That is because we need to reduce the particle size, and there we will be able to see some particles. Now don't be fooled by the fact that they look like spheres. This is just particles. If you turn off the display by spheres, and sprites, you'll see that they're literally just points. The difference between this and regular points is that it has IES green, mass, attributes incorporated into them. Okay, and that's it. That's how you create the grains. Now I'm gonna delete this, and I'm gonna leave 2 nodes for you guys. This is the resolution that I used on my simulation. You will see that it's pretty dense. I used 0.07 and I just left this caching for quite a long time. And for the sake of our tests, we are going to be doing 0.02 in scale, just so that we have enough grains for it to look cool. A little bit of dithering, which makes sure that it's not like completely uniform in the placement of the grains. And then I created this right here, which is out grains, because we're gonna use this layer now. And let's look at what we are plugging into this other input. Basically, what I did is the grains on top, and then you do a vellum solver. Then once you do the vellum solver, you connect this one here, and your collider in here. This is where we're gonna have our collisions. So our collisions we've already prepped. They're coming in through here. If we have a look, you will see that we have the placements on the scene, and then this is deleting our collider. Right? Remember that our collider will be this one. So on this end, right here, we're deleting everything but the particles area, and this one, everything but the collision area. And I am merging in the skull. If we click here, it'll show us where this skull is coming from, which is this area right here. And basically, this is where I created the animation that I like most. Right, so what I already showed you, and this is my out skull. And the reason why I have it here and I'm not using this one is because this one is higher resolution and this one is low resolution. You would do an object merge, and we just pull this in here. That will give us our skull. And I'm basically cutting this, so Ctrl X, root down here. Basically, this is just copying my skull, object merging in, and pasting it here so that I can have access to it when I do like as our collision. Then we're merging it in here, and that means that we are ready to test out the simulation. We have a pretty nice skull, a nice box, and it's animated, and yeah, all the goodies, right? So we plug it into the third input here. It says collision geometry onto our solver. And our solver, I will show you guys the things that I tweaked. So basically here I am increasing my substeps to a 10. What I'm gonna do is, just to show you guys, I'll do an object merge again. I will grab my low res skull and I'm gonna paste it here and connect it to the vellum solver without as many substeps. So substeps will give it more detail. Let's come into my camera. Substeps is gonna give it more detail. The forces, -9, gravity, which is the same as gravity, so the particles are gonna come down as soon as we hit simulate. And I'm not really changing anything else. That's basically it. Like if we come in here, we can add additional forces, but on this specific simulation, like I said, I just wanted it to be simple. Oh, oops. See how it's falling because we're not using this collider right here. So just for the sake of demonstration, just move this here, let's merge our collider that we created here. So now we have the same thing that we have in here, but low resolution. And now if we hit play, you'll see that the particles will collide, land perfectly and nicely with our collision surface. And it's gonna have a pretty decent collision with our skull. Now, of course, we see him jumping a little bit, the resolution isn't as nice, and that's all happening because we just two things. One, we need more particles. Second, we need more substance. Let's set this to 5 and resim. As you can see, the simulation is much slower, but it's also much more stable. You can now see that we don't have any jumping. All of the particles have settled in place, and the simulation is going to be pretty smooth. So that's basically the trick. Just playing with this. We already created a collider that is very tight and very nice, and the object will work nicely. So what I did afterwards is cache it. I'm just gonna delete this. What I did is cache the simulation to disk. For those of you who do not know what a cache is, I'll show you in a second. So you can see what my high-res simulation looks like here. All right, and what a cache is, we drop a file cache. I like to do explicit, and we're gonna type $os/$os.f.bgeo.sc. So basically the same thing as this is gonna create a file, and a file with this whatever name we put here, based on the $bgeo, meaning the cache file name of the sequence. Like you could do EXR for a render. For this type of file, we want a BGO so that it saves like each frame and then it loads faster. Okay, so that's the cache. Once this is cached, we have the sand simulation good to go. Now let's have a look at how to set up the skull to have some nice texturing. So the first thing that I did is I freeze the frame because I'm creating UVs. All right, so this right here is a tip. In case like you have an animation and you did the animation back at the beginning of your network, and you don't want your UVs to slip because the animation is taking place. That means that the UVs swim or the UVs move. So what you do to prevent that is that you freeze one frame and then you create your UVs on that frozen frame. Then we do an attribute copy, and we copy the UV attribute right here onto the animated geometry. So this one is frozen and this one will be animated. And you will see here that with this, the UVs will not slip and they will move with the animation. So I created this null here to say out skull because we're gonna be rendering the skull on a separate node. And on this right here, we're gonna render out our particles. So this is our sand and this is gonna be our skull. If we come here into our sand, you will see that I created an attribute randomize for the p-scale. And the p-scale global scale I set to 0.01 and the attribute name is p-scale. The minimum value that the p-scale goes is 0.3, so it goes from 0.3 to I1 in scale, And this is randomizing the scale of every single one of the particles. Then I created a attribute randomize again, and what I am using this one for is for the color. So this is giving me a random color for each of the particles. And then I'm creating an attribute bob, and inside of bobs, I'm saying my CD, plug it into a ramp, and then exporting this CD again. What this ramp is going to do is that it allows me to just tweak the random color, but only with these colors here. So I will let this for you guys because I played around with the colors quite a bit, but as you can see, like this is just gonna randomize the color random on your particles. And I found that this is a good variation for some interesting sand looking texture. And then here we're exporting the skull. So let's come back into here, and this is what we're gonna leave checked in for rendering the particles. We're gonna come out here and we're gonna create a new geometry node. Inside of this geometry node, we have the skull, and I'm gonna see object merge, bring it in. So we select here, we go into our sand, we look for out skull render, and this is the one that we're using. Then I painted it black, and then I did an attribute paint, and I painted some designs that I wanted to have. So attribute paint, let's drop this in here, let's connect it, and here you can first select it, then let's see. So we're gonna first select it, create an attribute paint. On the attributes, we're gonna paint CD for color. File hide, just refresh. Alright, sorry, I had a little bit of a brain fart there. We gotta make sure that we set CD here and then select color here. And then now we're gonna be able to paint. Let me turn off the UV so we don't see them. So here I'm just painting, and you can paint anything that you want as long as it's black and white, because we're gonna use that to separate the texture, the material. So you paint whatever design you want. And I wanted to paint this designs like this, and in my wrangle I said v at skull is equal to 1 because I wanted my skull to be a matte. And then last, we're just gonna say on this material render skull, which skull is the material that we're using. So we hit here, it's gonna take us to the skull, and this is the material that I am using to the skull. And don't worry, it looks a little bit intense, but we'll go through what each of these nodes does. And this is it, guys. I really hope that you guys enjoyed this long tutorial. I will be doing something that goes further in depth in terms of the simulation of the particles, the sand, and I'll be back with more.